So 5.6 notes covers, we're going to use congruent triangles and the idea that corresponding parts of congruent triangles are congruent to prove parts of triangles are congruent. So our goal today is to use triangles, triangle congruence, and CPCTC to prove that parts of two triangles are congruent. Now we actually did stuff like this back in section 1 of this unit. We showed, for example, I'm just going to write it over here. If triangle ABC is congruent to triangle DEF, that means that angle A is congruent to, and you'd look and say, angle D. Or if I said segment AB is congruent to, you could look and say A has to match with D, and B has to match with E. And so based on a congruent statement, you can come up with congruent parts. And the reason of that is because of CPCTC. What this stands for is corresponding parts of congruent triangles are congruent. C, P, C, T, C. Those are the big ones. So corresponding parts of congruent triangles are congruent. And so this is the idea from back in section 1. And so what we're going to do here is we're not being told that there's two triangles that are congruent. We're going to have to do what we've done in between 5.2 and 5.5 to identify if these two triangles are congruent. If we can write a congruent statement of them, then we'll be able to see is SQ congruent to PR. So what we're ultimately trying to answer here is yes or no. But before we can even answer that, we need to look at these triangles. So what I can see here is there's something else I can label. I only have two things labeled here. I only have two things labeled here. Remember, it's three things that will create a shortcut. So the other extra thing that I can label here is I can see that this is a shared side. So let's see if I can label what shortcut I have here. In this bottom one, I have two angles and a side. The side is not between the two angles, so I'm going to label it angle, angle, side on the end. Here I have two angles and a side. The side is not touching both angles, only one. So again, I have angle, angle, side. Now I want to go to my list. Is that a shortcut that works? Remember, you want to have that list handy of which shortcuts work and which do not. This is a shortcut that works, so with that, I can make a congruent statement. Name the first triangle however you want. Triangle PRS is congruent to triangle. P is the one that doesn't have the angle marked on it. So over here, the one that doesn't have an angle marked on it is S. R, PRS, is the one with one arc. So I have to go to Q, which is the one arc. S, PRS, in this bottom triangle, has the two arcs. P has the two arcs over here. So you need to make sure that order matters. Then I can say, okay, based on that statement, let's see what SQ is congruent to. Well, S has to match with P, and Q has to match with R. Is SQ congruent to PR? Yes, it is. And because of that, because of this is why it's so important that we make sure that order matters here, so you can see what that statement is to see if it is a yes or no. So the next one looks a little bit similar to the problem, that first problem we did. Again, it only has two pieces of information. It has two angles that are labeled. This has two angles that are labeled. I can see I do have a shared side. So So if I look at the triangle on the left here, I have two angles and a side. Now that side is touching both angles, so I want to make sure the side is touching, the S is touching both A's. I look at this one, I have two angles and a side. The side is also touching both angles, angle, side, angle. So that is a shortcut that works. So we're going to name that first triangle, triangle ABD. You can name it however you want. Is congruent to triangle A has to match with C. That's the one that doesn't have any labels on it. B has to match with B. Both of the angles at B have one arc. Both the angles at D have double arcs. So that's my statement. Okay. Now I'm trying to figure out, is AB, let's figure out what AB is congruent to. AB is congruent to, let's check. A has to match with C. B has to match with B. And if you look here, AB congruent to CD, no. That's not the statement we came up with. So because of that, we answer no. And we're done with that problem. All right, so this one here, again, we have another shared side. So if I mark it, make sure you use a different mark than the two that we've already used. So we're going to use 3 dashes there. The bottom triangle, if you look at it, you have side, side, side labeled. The top triangle, if you look at it, you have side, side, side labeled. So that means SSS is a shortcut that works, so we'll be able to name triangle MOE congruent to MOE through the 1 dash, through the triple dash, through the 1 dash, through the triple dash, REO. Okay. Now, let's figure out what angle M is congruent to. Angle M is congruent to, it has to be in the same spot as angle R. M is congruent to R, yes. We can answer yes on that one. So you have to be able to come up with, look at the diagram, label what you can. Are the triangles congruent? The triangles are congruent here by side, side, side. This statement here is by CPCTC because corresponding parts of congruent triangles are congruent. All right, this one here. We can label vertical angles are congruent. Let's look. We have two sides and an angle. The angle is on the end, not in between, so we have SSA. On this one, we have two sides and an angle. The angle's on the end, so we have SSA. Now, unfortunately, SSA, that's that bad word spelled backwards, so we cannot use that as a shortcut. We could see if we're able to here. Could you use HL theorem? Well, you could try, but we don't have any right triangles. There's nowhere that anything's marked as a right angle. So because we don't have right triangles, we can't resort to the HL theorem. So this one, we cannot determine if triangles are congruent. So you can't make a congruent statement about the triangles. So this one is cannot be determined. And really, we should label that's how, instead of saying no up here, we should write cannot be determined as well, because we don't know for sure if it is a no, but we are for sure that it is, we don't know, we're not sure. So you write cannot be determined versus the no. Okay, so flip it over, and on the back side, we have two proofs that we're going to go through. So, just like always, let's set up our proof with the information that we have. We have a given is angle ABD is congruent to angle CBD. Our reason is given. We also have that angle BDA is congruent to angle BDC. Reason is given. And what I'm trying to prove is that AB is congruent to CB. Now, since I'm not proving triangles congruent here, I know that what I need this statement above it to be is I'm going to have to try to prove triangles congruent. So I'm going to have triangles are congruent in the step before, okay? This is going to be some kind of a shortcut, one of your shortcuts that work. Now don't use SSA or angle, 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 AAA, because those are shortcuts that don't work. So we have to use a shortcut that works here to prove triangles congruent. Then we'll have to show that AB and CB are the same, and we know that if we're proving parts, it has to be from corresponding parts of congruent triangles are congruent, CP, CT, C. So I know this is going to be the setup of my proof. Now I have to go back and actually fill in the blanks here. But if you see that you're proving parts, that's going to be your last statement, your proof, and your reason has to be because of corresponding parts of congruent triangles are congruent. So let's take the givens, let's label them in our diagram, because you always want to label in your diagram. ABD, this angle here, is congruent to CBD, this angle here. BDA is this one here, and it's labeled the same. Oh, you can't really see that. Move this down, sorry about that. BDA is congruent to BDC, so we're going to make sure those have matching arcs. All right, now let's see what else we can do. Based on our diagram here, I can also see that I'm going to have a shared side. So now this one, you don't have a congruent statement to really double check that order. So BD, if you look at it from this one, it's going from the single arc to the double arc. So when we look at this one, it has to go from the single arc to the double arc. So it's also BD. So then let's figure out what shortcut is used then to prove this triangle congruent. So if I look at this one, I have two angles and a side, so an angle, angle, and a side. The side is between the two angles, so it has to be angle, side, angle. I look at this one. I have two angles and a side. The side's between them, so angle, side, angle. That's my shortcut for both. So that's my shortcut for how I prove these triangles are congruent. So I'm going to name the first triangle BDA. Is congruent to, started with the one arc, went to the double arc, went to the no arc, BDC. Okay, now double check. A matches up with C, B matches up with B, and I know that reasoning is because of corresponding parts of congruent triangles are congruent. So we have been working on proofs up to step 4, okay? The new part about this section is that we added in step 5. So if you've been confident in proving the triangle is congruent, that takes you to step 4. Your 5th one is using that corresponding parts of congruent triangles are congruent, which is something we actually learned in 6.1, but now we're adding it on to proof. All right, let's look at this last one. Again, let's start by just writing out all the stuff that we know. So I have angle SPT is congruent to angle OPT. My reason is given. I know that segment SP is congruent to segment OP. My reason is given. I know that I'm going to have that angle O is congruent to angle S in my last step. I already know my reasoning here, even though typically you don't know your reason in your last step because usually you know you're going to be using a shortcut. This one, because it's parts, I know I'm going to have to use CPCTC. That's the setup to this proof. I also know since I'm using that, my step right before that has to be that triangles are congruent, and this will have to be a shortcut that works. So there's my setup, and then I just have to go through and fill in the missing parts. So starting with, let's label the givens. Angle SPT, right here, is congruent to OPT. right there. Segment SP here is congruent to OP here. And that's all my givens. Now I have to see if there's something in addition to that that I can label, and I can see that I have a shared side here. So TP is congruent to TP. Shared side. And now let's look at what our triangle congruence is. So triangle TPS is congruent to triangle TPO. And my reasoning, let's look here. I have two sides and an angle, and the angle's between the two sides, side, angle, side. Over here I have two sides and an angle. The angle's touching both sides, so put the angle in the middle. My reasoning, my shortcut, is side, angle, side. And then just double check. Are your O and your S in the same spot? They are. That's why you can mark those angles congruent by CPCTC. And those are your notes for 5.6.